How's it going, everyone? Welcome. Eliar Gonzalez here. And let's go to now explore about the using closures in today's video as a way to understand now this particularly chapter in this book and finally knowing or closing the gap or weaving our knowledge here of why do we even care about looking at the JavaScript, particularly at the scope and variables, how they relate each other's in some high-level abstractions that are relevant in our JavaScript developing of applications that by exposure only the least amount of variables we can eliminate a classes of bugs. And also it comes with the decision of deciding which of this practice we need to set as a way to now define programs and how they relate each others. So the whole point of exploring the using closure and the principle of least privilege as well as the model patterns is to understand now how to apply this kind of decisions, all right? So where do we need to apply when we are starting to write our code, when we need to define how our code will interact and how they're going to interact, right? So with the principle of least privilege, with the least exposure, Kyle Simpson actually described that as a way to get ourselves the sense of why is it useful for us to now in a particular scope only expose is the relevant variables or keywords, right? So as opposed to going into other more broad topics like this in the chapter 7 in using closures. So up to this point we have focused on the ins and outs of the lexical scope and how that affect the organization and usage of variables in our programs. Our attentions again shift broader in abstractions to the historically somewhat daunting topic of closure. Don't worry, you won't need an advanced computer science degree to make sense of it. Our broader goal in this book is not merely to understand scope, but to more effectively use it in the structure of our programs. So closure is central to that effort. Exactly. So how can we organize? So not to just understand scope for the sake of doing that, but to also look at how can we structure programs, and closure is a central of that effort. So recall the main conclusion of chapter 6, which is the least exposure principle, encourage us to use block and function scoping to limit the variable exposure. In other words, is just to put those variables that are relevant into that scope as it is. So this helps keep code understandable and maintainable and helps avoid many scoping pitfalls. For example, like name collisions, unintended dependency exposures, and unexpected behavior as well. But this is more likely for JavaScript, pure JavaScript. So right now we're using is TypeScript. So this kind of issues, for example, the unexpected behaviors are gone, but we still have the name collision and the unintended dependency exposures here. So this helps keep code understandable and maintainable and helps avoid many scoping pitfalls, right? So closure builds on this approach, For variables, we need to use over time. That's the whole point of this. It's say, hey, let's going to structure our code, but instead of overexposing it, instead of reducing the surface area, when you need a variables over time, okay, uh, instead of placing them in larger outer scope, we can encapsulate more narrowly scope them, but still preserve access from inside function for broader use. Functions, remember, this references scope variables via closure. So we already saw an example of this kind of closure in the previous chapter, for example, factorial. Yes. And you have almost certainly already used it in your own programs. If you're ever reading a callback that accesses variables outside of its own scope, exactly. Guess what? You are using a closure. Closure is one of the most important language characteristics ever invented in programming. It underlines major programming patterns, including functional programming, exactly, including functional programming, models, and even a bit of class-oriented design. Getting comfortable with closure is required for mastering JavaScript and effectively leveraging many important design patterns. Let me place to begin. So anyway, exactly. So closure is one of the most important language characteristics ever invented in programming, and it underlines major programming patterns, including functional programming, models, and even a bit of class-oriented designs. Getting comfortable with closure is required for mastering JavaScript and effectively leverage many important design patterns through our code. Addressing all aspects of a closure requires a daunting mountain of discussion and code throughout this chapter. So make sure you take your time and ensure you're comfortable with each bit before moving to the next one. See closures. Closure is originally a mathematical concept from lambda calculus. So this lambda calculus, all right, is a formal system for expressing computations based on functions abstractions and applications using variable bindings and substitutions, which is pretty much what we are doing anytime that we write this particularly functions. That is a formal way to expressing computation for these functions and applications using variables, binding, and substitution here. So this, but again, it's a formal system, right? So lambda calculus is a formal system for expressing computation. Okay. For expression computations. Instead, I'm going exact, but for again, this is a formal system for expressing computation Okay, it's a formal system for expressing computations based on functions, abstractions, and applications, in variable binding or using variable binding and substitution. Lambda calculus is Turing complete or computationally universal if it can be used to simulate any Turing machine. And it is universal model of computation that can be used to simulate any Turing machine. It is namesake the Greek letter lambda, and it is used lambda expression in lambda terms to denote binding a variable in a function. Lambda calculus may be on type or type. In type lambda calculus, function can be applied only if they are capable of accepting the given input's type data. Type lambda calculi are strictly weaker than the on-type lambda calculus, which is the primary subject of these articles. But in any case, but is this? So, I'm not going to list out of the math formula or use a bunch of notation and jargon to define it. Instead, I'm going to focus on a practical perspective. We'll start by defining closure in terms of what we can observe in different behaviors of our programs, as opposed to if closure was not present in JavaScript. However, later in this chapter, we're going to flip closure around to look at it for an alternative perspective. But here you're going to see what the observable behaviors in JavaScript. Closure is a behavior of functions and only functions. If you aren't dealing with functions, closure does not apply. An object cannot have closure, not, and as I mentioned, and when I look at the definition of that, is to say, hey, we cannot. The lambda calculus is this formal. It's a formal system. It's a formal system for describing computations with functions, abstractions, using variable bindings, right? This is what is the thing you need to actually have a more practical sense to do this. And we'll start by defining closures in what we can observe in different behaviors of our program, as opposed to if closure was not present in JavaScript. However, later in this chapter, we're going to flip closure around to look at it from an alternative perspective. So closure is a behavior of functions and only functions. As I mentioned before, only functions have closures. So for closure to be observed, which is a function that you want to use over time, all right, for variables that you want to use over time, for closures to be observed, a function must be invoked, and specifically it must be invoked in a different branch of the scope change from where it was originally defined. A function executing in the same scope it was defined. A function executing in the same scope it was defined will not exhibit any observably different behaviors with or without closure being possible. By the observational perspective and definition, that is not a closure. So let's look at some code annotation with it is relevant scope bubbles color here, like so, right? But again, anytime that you want to have access to a variable, anytime that you want to use a variables over time, if you do that inside of a variable from the other scope, that's when you create a closure. So for example, here we have is the lookup student, which is attached to the global scope identifier, and then you create now is this function scope with the student ID identifier, the student identifier, and then it's going to now return is a function that has the greet student identifier as well as the greeting. So it creating is the greeting student function scope, okay, as well as the student identifier that is accessing to the student identifier that it doesn't belong to this scope, it belongs to the outer scope here, right? Do some computations, assign that to a variable, and then you're gonna get this. So you're gonna show the greeting by the student as it is, right? So in this case, you say, hey, I do want to know is, since I'm gonna return is a function here, right? On the choosing student, what it's gonna do is to now run that function, all right, and gonna give it that a function with student, all right. So what it's doing here is to call this function, right? Now what it's doing here is to only call this function, and then you're gonna now have a reference to that function. The same for this, right? You'll have now a reference to that functions. All right. So what we're doing here is to now, by doing this, we are accessing to the function name, right? The greet student, all right. And then when you want to call that function, you just pass the property as it is. Hello, Sarah, and so on and so forth. The first things to notice about this code is that the lookup student outer functions creates and returns an inner function called greet student. And lookup student is called twice here, exactly. It's called twice here, producing two separate instances of the inner greet student. All right, exactly. So when you're doing this, you're creating is now two different instances of the greet student here function, both of which are saved into the chosen student array. We verify that's the case by checking the .name property of the return function saved in chosen student 0, and it is indeed an instance of the inner greet student. After each call to lookup student finish, it will seem like all it is inner variables will be discarded and garbage collected here, right? After each call of the lookup student finish, it will seems like it is inner variable will be discarded and garbage collected here. So the inner function is the only thing that seems to be returned and preserved according to this, right? So it might feel your intuition, it might fit your intuition here. And it will seems like an inner variable will be discarded and garbage collected here. So the inner function is the only thing that seems to be returned and preserved. But here's where the behaviors differs in where we can start to observe. While greet student does receive a single argument as a parameter here, named greeting, it also makes a reference to both student and student array, identifiers which come from the enclosing scope of lookup students. Exactly, of lookup student. Each of those reference from the inner functions to the variable in an outer scope is called closure. In academic terms, each instance of a grid student, exactly. In academic terms, each instance of grid student close over the outer variable student and a student ID if they have access to exactly of a student and a student ID. Um, So why do those closures do here? In a concrete observable sense, closure allow grid student to continue to access those outer variables even after the outer scope is finished. When each call to lookup student completes, instead of the instance of a student and student ID being garbage collected, they stay around in memory. At a later time, when either instance of the grid student function is invoked, those variables are still there, holding their current values. So if JavaScript function did not have closure, the completion of the lookup call will immediately tear down its scope, and the garbage collector uh, the student and student ID variables. So when we later call one grid student function, what will happen then? Well, the grid student tried to have access to what it thought was the blue marble, but the marble did not actually exist anymore. Exactly. So the grid student will try to have access to variables that are outside of its enclosing scope, but those variables uh, don't they don't exist anymore, right? So the reasonable assumption, if we get the reference errors, right? But we don't get an error. The fact that the execution of chosen student 0 and hello world and returns us the message hello Sarah means it was still able to access to the student and the student variables. This is a direct observation of the closure. Exactly. So, but in any case, the TLDR of closure is that when you want to use a variable over time by using a function and defining this identifier inside of it from an outer scope, so you are creating is a closure. Mm-hmm. 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 So example of using a variables um, yeah, example of using a variable even after or example of using a variable um, yeah, example of using a variable um, example of using a variable over time is, for example, is counters or time series data. uh, that'll be a good example of this. Mm-hmm. So what are examples what are real time or real world examples of, yeah, what are real world example of uh, variables used over time closure in JavaScript? So for example, counter is one of them. Or anytime that you want to keep track of something. Alright? So for example, keeping state as well. Mm-hmm. Event handlers. Okay, so anything, so event handlers, debouncing search inputs, interesting. Uh, Event handler with state, exactly. So for example, like this, uh, event handlers, counters, debouncing search inputs, uh, private variables, data hiding, function factories. All right. Function factories. React hook patterns is another one. Memoization and caching. The key insight is that closure allows inner functions to remember and access value from their outer scope even after the other function has returned. And this creates persistent private states without needing global variable or classes. But anytime that you do wants to do that, um, so for example, with event handler with states and the bounce search input, and I do get a why the bouncing here. You gotta get this function in the delay. And then after an X amount of time, okay, uh, I do want is to now execute that function with this kind of arguments here, right? So you hold the reference of the function as well as the delay to do so. A debounce here. Okay, so for the debounce, you say, hey, this is debounce that I do want is to now execute a function after an X amount of time, all right? And since I'm going to schedule this with the set timeout, all right? What I do want is to now is hold a reference here. So passing all of this variable, all of these identifiers to hold a reference. And when I call that function, well, I actually now is going to tell, we're gonna say, hey, this is the function that I do want to apply. Okay. So this is the function that I do want to apply here. Yes, this is the function that I do want to apply that say, hey, if we already have any interval, let me clear that interval out, timeout, all right, and then now set the set timeout to say, hey, I do want is to now execute this function here as an anonymous function here, and then somehow receive the arguments, aka in this fashion, right? So get all the arguments here as an array, all right? And then now, by the time that I call these functions, okay, I want to schedule this function here along with all of the arguments, all right? Exactly. And then now do that after an X amount of time. So now that I have this debounce, and when I call that or to assign to a variable, it can say, hey, debounce, this function that I'm gonna say says, so this is a query, all right, and here I do want is to after an X amount of time, let's say 1 second or 2 seconds, I do want is to is well, just to console log is the query, right? So because this is the function that I do want to attach to, I can attach that functions to a particular input. Okay, I can say window the name of the input, right? the ID of that input. Let me see if you have already ID here. Diggy diggy. No, it's not here. Then you have an ID or the input. That's interesting. They hide that input. So they don't have any input. There is a field set on the bottom here. But there you got the input is hidden. The input is hidden. Look at this. They don't want to expose that. But look at that. Chat input done. Now that I identify that, all right. So I do have now here is the. Let me actually do this. So I do have now this is the input, which is the elements. Okay, element input, right? And then I can say something like this. Hey, I'm gonna put it just called this element input, or you can be more explicit about and say chat input. But this is chat input file upload. Okay. Okay, that's good. Chat input file upload. So chat input file, all right. And any time that I listen to the chat input, I can add an event listener to say, hey, anytime that you change, I do want to now apply is this particular function, which is the debounce, all right. Yeah, I do want is to do is this. I do want is to call the debounce, all right, and say, hey, you're gonna say debounce, debounce 2 seconds, you know, debounce 2 seconds, like this, and which is I do want is to now is execute this function here that I'm going to pass to you, or I can say something like this. I do want to pass now is the debounce here, all right, that of course I'm going to now get is some data, all right, or I'm gonna get is the event, but I do want is to now is pass the event here to the debounce, all right, to say, hey, the event dot target dot value is this. Is to say, hey, just print that out, right? You know, in our case, this is all what I want to do, just like that. I can say is this to be much more explicit about this. And then I want to just render is or show you the value here after 2 seconds, right? Syntax in declaration context, line 15. Because editing closes that. Exactly, because I didn't close that. And there you got it. This is for this. Let me create now. Here is a code pen of that. So if I create now a code pen, which is this one, and I can say is document get element by ID. All right, which is this one. Chat input file add event listener to that, and on change. And let me do is this, right? Let me do is chat input. All right, chat input. Okay, and here define is the input type text, right, with the ID of chat input. All right, there you got it. And well, once I now do on change, I should be able to say, hey, this is an illegal property declaration context. Was a clear timeout. Clear interval. Clear interval. Okay. Okay. It is because it's clear timeout. Clear timeout. And set timeout, and then I need to attach that timeout because it's gonna return is now a ID to do that. And the debounce we can say is debounce. All right, to the chat input or debounce handler. Debounce handler, which will be is that calling debounce with this function. All right, all what I want to do is to just console.log that value, right? Say value, and then pass this the amount of time that you want to. So by the time that you call that event listener, so on change, okay, now what we have to do is this. It's just to call now is debounce handler, and pass the event dot target dot value to do that, right? Chat input is not defined. You're right. There you got it. Okay. Cannot read property. Add event listener of null because it is this one, chat input. All right. And now, after an amount of time, it's a you're gonna get is this. So if we want to now show that particular value there, let's say div here. Let me wrap this in a div to say, hey, this box that'll be h1. All right. Say delayed input. Okay. Let me put it not that huge. Not delayed input. And then what I want to do is to append all of those elements here. And here I can say, hey, the ID of this element that I'm gonna grab here, okay? Or since this is now is a small chunk of HTML, right? I can say is, let me now grab is the list by say document query selector of the unordered list, all right? And then anytime that now something change here, all right, or anytime that time has passed, I then do one is to now is, you put it in this way, I then do one is to now after the debounce has been called, okay, I then to now append that value, right? So because this is an async function that is gonna be that's gonna happen inside of this, okay? So what we can say is, well, instead of printing that out, I can is now is call to the list, effectively creating now a closure, okay, and say add and say append child, right? That is going to append so I can say is this. So I can say is, let me now is grab this value. So once I have this value, then I want to add that to the DOM. All right. So in order to add that, we can is do something like this. All right. And say, hey, first I do want is to have now a reference to that list. So I have them, right? But I do also want is to create now is the element here, which is the element, right? And which is the element. And this element as a variable here, I do want is to define this as it is. which is the debounce value comes element, is to say document create element, all right, to say, hey, this will be is now, let's say, an in a list item, right? That this list item will have is now the text content, yeah, the text content, HTML element, exactly, the text content, the text context, the text content will be the same as the value, right? And then I do want to append that child to the element, right? I want to append the element to this list, and that'll be all, right? So it's going to now grab that element for us, you know, the list, okay? And grab me only the first one, and then you do this kind of stuff. An unexpected token, where? Append child, or you can say append element. Mm-hmm. Oh, okay. List append element is not a function. Append child, exactly, is append child here. Document query selector UI L. Okay, consider using its input other than that. Okay, so there's some very little nuance here. This is a basic example of that. But again, it's because the whole point that we did here is with this particular functionality. Hey, I do want us to keep track of this functionality and I want to keep track of these variables. That holding is functionality and the value, right? And after an X amount of time, I do want to create now this, bro. Holy moly, bro. Holy moly, bro. Absolutely. Mm-hmm. Mm-hmm. And receives the value and the list. And receive the list and then the value as it is, right? So I don't, so now the list element that is being used is now locally, not from the outer scope. Coño, qué arrecho. Not from the outer scope. Mm-hmm. Interesting. Interesting. Mm-hmm. A very silly example of a debounce here. Mm-hmm. 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 And an input here. Type text, an ID of that, get element by ID, chat input. All right. And here you say lower here to say h3. It's gonna wrap this into a new block. All right. So it's going to put this element. It's gonna render this element right after the input. All right. And then now push the x3 here, followed by this content, and say, hey, delay, or say 2-second delay. 2-second delay, right? And here we're gonna put now this unordered list element, that I want to now dynamically append those elements in there. So by the time that I do this, it's gonna put there after 2 seconds. So I can string that to say, hey, I'm gonna put it after 1 second. After when the debounce here, delay, right? To be more descriptive again, to avoid using is magic numbers, okay? And there you got it. You see? This is a silly and powerful example here, because here we're using is on the debounce to say, hey, I do want to run this functionality here after an X amount of time, and then somehow I want to store these variables, this information, in access only when I call this, which is when I return this function and I receive these parameters and so on and so forth. I do want to is clear, of course, interval if I have that, and then now schedule this task via the timers, and assign that to the timeout to hold a reference to this, right? That's holy moly. And here what we did is just to say, hey, well, what'll be the to reduce the constraints of that. That's what we're doing here. Is to reduce the exposure here, to avoid certain kind of errors, unexpected behaviors, unintended dependency. For example, if I don't do this, right? So then I have now unintended dependencies, right? Holy moly. That'll be all for this video. Take care. Bye bye.